At first glance, it seems like the square root of x squared should equal x. Let's compute some examples to see why this is not always true. If x equals 2, then the square root of x squared is the square root of 2 squared, and 2 squared is 4, so this is the square root of 4, which is 2, the x we began with. So it looks like the square root of x squared equals x in this case. What about if x is 3? Then the square root of x squared is the square root of 3 squared, which is the square root of 9, which is 3, the number we started with. Again, it seems like the square root of x squared should be x. But what if we try x equals 5? Then the square root of x squared is the square root of 5 squared, which is the square root of 25, which is 5. Again, it looks like it's true. All of these examples make it really seem like the square root of x squared does equal x. But all of these examples have something in common. They're all positive. What if we look when x equals negative 2? Then the square root of x squared is the square root of negative 2 squared, and negative 2 squared is positive 4, so this is the square root of 4, which is 2. This is not negative 2. Our equation is not quite true here. So the square root of x squared was positive even though x itself was negative, because when we squared x, it became positive. So the square root of x squared equals x if x was positive to begin with. And the square root of x squared equals negative x if x was negative. And remember, if x is negative, then the negative of x is positive. So the square root of x squared is x when x is positive, and negative x if x is negative. But we've seen this function before. It's the absolute value. So we can conclude that the square root of x squared is not x, but the square root of x squared equals the absolute value of x.